we're going to look at graphing square root functions and square root inequalities. To make it easier to graph, we're going to start out by finding our domain, looking at what our range is, and then also finding our x and y intercepts. Now, remember, when you're dealing with a square root, what's on the inside can't be negative. So what's on the inside, if it can't be negative, has to be greater than or equal to 0. So I'm going to take what's on the inside, which is the 3x, or 3 over 2x minus 1, has to be greater than or equal to 0, because I can't take the square root of a negative. So if I solve this, it's going to tell me my domain. So I'll go ahead and add 1, and then multiply both sides by 2/3. So my domain is x is greater than or equal to 2/3. Now your range is the types of y values that you get out. Now notice here, what's in front of our root is a positive sign, so that means we're not getting out any negative answers. So we can't get out negatives, so our range has to be greater than or equal to 0. Now to find our x-intercept, your x-intercept is when your y value is 0, so we're going to plug in 0 for our y value. And then all we have to do is go ahead and solve this. And we've looked at solving radical equations before. We'll square both sides, then we'll have to go ahead and add 1, and then we'll have to go ahead and multiply both sides by 2/3. So we're going to be crossing our x-axis at 2/3. Your y-intercept is when x is 0, because you're not up and down, or not up and down, I mean you're not left and right on your graph, you're right on the axis, so that means your x is 0. So if we plug in 0 for our x into our original function, that's going to allow us to be able to work this out. However, we know we don't have a y-intercept because x is not part of our domain. We had set up here our domain was greater than or equal to 2/3 for x, and 0 is not greater than or equal to 2/3. So try to find your domain, range, and x and y intercepts of this function, and then watch the video. Your domain, sorry about that. You take what's on the inside for your domain, you take what's on the inside of your root for your domain, and it has to be greater than or equal to 0, because you can't take the square root of a negative. So we eliminate the negatives, and that leaves greater than 0 positives, or equal to 0. We solve that by subtracting a 2 and dividing by 2. Range, what we have right here is, just a second here. What we have in the red box, we look in front of our root, and it's a positive, so that we know we're not getting out negative. So everything in the red is greater than or equal to 0. But if we take everything in the red that's greater than or equal to 0 and we add 3, that means our range will have to be greater than or equal to 3. Now your x-intercept is when y is 0, so we'll plug y being 0, and then we'll solve that. Remember, we got to get our root by itself by subtracting 3, then we can square both sides, and we get this. But remember, in solving radical equations from earlier, we need to go ahead and take our answer and check it to see if it works. And in this case, it doesn't work. Now, let's take a look at, as in what I mean it doesn't work. If you take 7 or 2 over 2 and plug it into the original, it does not actually give you out 0. It's an extraneous solution. Your y-intercept, you plug in 0 for x, and we get the square root of 2 plus 3 is your y-intercept. Now, we knew that we did have a y-intercept because your y-intercept is where you cross the y-axis, and that's when x is 0, and x being 0 is part of our domain. So let's go ahead and graph this. Well, first of all, we're going to start off by finding our domain. So you take what's on the inside of your root, set it to be greater than or equal to 0, and then we solve it, and we get x is greater than or equal to negative 5/3. So then we're going to make a t-chart, starting at negative 5/3, and then just drawing the nice normal numbers above that. Then we could go ahead and plug those in, and we would get this. Now remember, we could go ahead and plug that into our y equals, and just go ahead and look at our table. Oh, I messed that up. Sorry about that. So we have it inputted correctly. Then we can go ahead and look at our table set. Negative 5/3, that's starting at about -2. Now, it doesn't necessarily handle nicely this fraction. So you're going to probably have to put that fraction in by hand. But that's not too bad because -5/3, -5/3 times 3, the 3's are canceled, leaving you with -5, and -5 plus 5 is 0, and the square root of 0 is 0. So that's easy to get. So really all we have to do is go ahead and start our table at -1. So look at our table, second graph, and then you can see that you get these points here that match up over here. Then you plot those points. Plot your initial one over -5/3, up 0, over 1, up 1.4, over 0, up a little bit more than 2, and so on. We know it's going to be dotted because there's no greater than or equal to here. Greater than or equal to, when y is larger than, that means you're going to be taking your graph and you're going to be shading where the y's are larger, which is shading straight up. So this is what your graph will look like. If you wanted, you could go ahead and try the point 0, 0, plug it into your original function, and in this case it would not work, so you'd want to shade the other side. Go ahead and try to do this one and then watch the video. Take what's inside to find your domains, what's inside greater than or equal to 0, solve it, then you make yourself a t-chart, plot those points, y is less than or equal to, so you know it's going to be a solid curve, and y is less than, so you'll be shading below. So you plot your points, solid curve, shade below. See if you can go ahead and find the range and domain of these four. Not necessarily graph them, but find the range and the domain. This one here, you take what's on the inside, greater than or equal to 0, you'll get your domain to be x is greater than or equal to 5. Now keep in mind, for your range, what we get out here of your root is a positive, because there's no negative. So it's greater than or equal to 0 here. Times 2 would still be greater than or equal to 0, but greater than or equal to 0, greater than or equal to 0, but then you have to go ahead and add 4. Greater than or equal to 0 would be y is greater than or equal to 4 for your range. Looking at this one here, what's on the inside has to be greater than or equal to 0 for your domain. So you go x plus 5 greater than or equal to 0, and you get your domain then to be x is greater than or equal to -5. You'll notice what you're getting out here is not positives, but negatives, so your range is less than or equal to 0 here. But if it's less than or equal to 0 for here, and then you add 4, that would be less than or equal to 4 for your range. For your domain here, what's on the inside, greater than or equal to 0. 5 minus 2x greater than or equal to 0. You get -2x greater than or equal to 5. And then you get x to be less than or equal to 5/2. For your range, you're getting out negatives, so this is less than or equal to 0. Less than or equal to 0 minus 9 would be less than or equal to 9 for your range. Over here, your domain is going to be setting the inside greater than or equal to 0. You're going to get x to be less than or equal to 8. Then for your range, you're going to be getting out greater than or equal to 0 here because it's a positive in front. Greater than or equal to 0 minus 7 would be your range being greater than or equal to 7.